Hey guys, welcome. So I thought instead of conducting a live class, recording this offline video would be a better approach. However, we will be having a live discussion session sometime later this week on the topics that I end up posting. So if you have any questions, you can ask them during the discussion session. I will be posting the details of the discussion session in Classroom, so please keep an eye out for that. Okay, so without further ado, let's get started. We were basically going over transmission media, and so far we have looked at so twisted pair cable, and we already went over coaxial cable. All right, so twisted pair and coaxial cable, we already covered those in class. So I'm going to be starting fiber optic cable. So in twisted pair and coaxial cable, the inner conductor was made of copper. Now the fiber optic cable is made of glass or plastic and transmits signal in form of lights. So basically a fiber optic cable, to see the blue region over here, this is the core. The core is made of glass material, and that is surrounded by cladding, which is also made of glass material. Right? So in a fiber optic cable, the optical signals are carried by photon pulses, and they move through glass strands or optical fibers. Now, the light waves are produced either by LEDs, that is light emitting diodes, or they're produced by injection laser diode. Now at the transmitting and the receiving end, signals are converted from an electric signal, and they're converted back to an electric signal by optical modems. And one such example of an optical modem is avalanche photodiode. Right? So in order to really understand optical fiber, we first need to explore several aspects of the nature of light. Right, so we know that light travels in straight line as long as it's moving through a single uniform substance. So let's say the light is traveling only through air, and it will be moving in a straight line, right? However, if a ray of light traveling through one substance suddenly enters another substance, and given that the densities of these two substances are different, the ray changes direction. So light, when moves from air to water, it changes direction, right? Depending upon the densities of these two surfaces. So let's look at the first figure over here. So you have all right, so basically you have a surface over here. The blue surface is the more dense surface, and the white surface over here, this is the less dense surface. So this figure kind of shows how the light ray changes direction. So all right, so let's draw a normal, like this dotted black line would be the normal to both the surfaces, right? So, and this pink arrow over here, this is the light ray. So when the light ray is moving from the blue surface to the white surface, it's changing direction, right? So this phenomenon is called refraction of light. Okay, so the light ray, it's making an angle with the normal that we just drew, right? The perpendicular we just drew. This angle is called the angle of incidence, right? And the refracted ray, the angle this makes with the normal, this one is called the angle of refraction. Okay, so let's look at the next figure. What's happening over here is if we increase the angle of incidence, then for that angle of incidence for which the angle of refraction is 90 degree, that angle is called the critical angle, right? So in this example, the light ray, for this angle I, you see the refracted ray, it's touching the surface of separation of this blue surface and the white surface, right? It's touching exactly the surface, right? So, and it's making 90 degrees with this dotted line. So this angle is called critical angle. Now, if the light ray is incident on an angle greater than the critical angle, so you see I over here, now this angle of incidence is greater than the critical angle because the critical angle was just this much. Then the light ray gets reflected back into the first medium. Now this phenomenon is called total internal reflection. Okay, so this is exactly the property of light that's used by fiber optic cables. So basically, in an optic fiber cable, it uses reflection to guide light through channel. So you basically have a glass core. So, right, so this yellow region over here, this is the core. This core is made of glass material, right? And the core is surrounded by the cladding, this blue region over here. And the cladding is also made of glass material, but the density of the core is higher than the density of the cladding. So core has a higher density than the cladding. So when the sender is sending this light ray, if it's incident at an angle greater than the critical angle, so at the surface of separation, obviously the light ray gets reflected back into the first medium, right? We just looked at it a while back. So this total internal reflection, this property of light ray is used by optical fibers. So that is how the light kind of propagates. So fiber optic cables have a lot of benefits. The biggest benefit being that it has a really high data rate, and it's smaller in size, and it has a lower attenuation rate. So since it has a lower attenuation, you don't really need a lot of repeaters to repeat the signals. And it is also immune to corrosive materials because it's not iron, it doesn't rust, it's just made of glass, so it doesn't really corrode. Right, so these are some of the benefits of fiber optic cable, but there are also some limitations of fiber optic cable. One of them being that since the inner conductor is made of glass, and glass is extremely fragile, so they break very easily, so you need to handle them carefully. Also, they are more expensive than copper media over the same distance. These are some of the challenges of fiber optic cable. Right, so fiber optic cables are actually used in different types of networks. So far we have looked at some network types like LAN, WAN, MAN, PAN. These were some of the network types that we looked at previously. And here you will get yourself familiarized with some new terminologies for networks. So you have long haul trunks, metropolitan trunks. So a long haul trunk is a network that ranges roughly about 1,500 kilometers and consists of 20,000 to 60,000 voice channels. So these are basically different types of networks, and they use fiber optic cable. Here are some pictures of fiber optic cables for you guys to see. All right, so fiber optic cables, we talked about, like when you're producing the lights, you either use LEDs, light emitting diodes, or injection laser diodes. So the advantage of using LEDs are cheaper and they have a wider operating temperature range, and also they last longer. But if you use injection laser diode, it's more efficient and they have a higher data range, right? So previously, we talked about multiplexing techniques, analog multiplexing techniques in particular, frequency division multiplexing and wavelength division multiplexing. Now, optic fiber cable, it carries optical signals, right? So light rays are basically just analog waveforms, right? So to multiplex those, we normally use wavelength division multiplexing. So fiber optic cables, if you want to multiplex signals there, you mostly use wavelength division multiplexing, right?